Hi, my name is Nellie the Neuron, and this is my life.
Before Nellie goes into her story, let's review what makes up a neuron. A neuron is a nerve cell. Her cell body is where the nucleus is. It's like every other cell you know. However, her other characteristics that make her a unique type are the dendrites, axons, and synaptic terminals. She has multiple branching fibers that receive or detect certain stimulus. The axon is her long tunnel-like extension that transmits signals to other cells. Synaptic terminals are the few other branching fibers off of the axon that deliver neurotransmitters, which we will talk about later, to other nerve cells.
Usually I am a really calm neuron. I say at resting potential.
Before she goes off on another tangent, let me tell you more about resting potential. Every cell has a membrane potential, which is a voltage difference in electrical charge across the plasma membrane. When a neuron is not sending signals, it is in what we call resting potential. A neuron's resting potential is usually between negative 60 to negative 80 millivolts, with a negative inside cell. Ions are what maintain this voltage, and the most important ions for Nellie are potassium and sodium. They fluctuate in and out of the membrane and of Nellie through what we call a sodium-potassium pump. This pump uses ATP energy to push sodium out of the cell and potassium into the cell, with a 3 sodium to 2 potassium ratio to maintain the negatively charged inside of the cell.
Sometimes I get a little upset when other neurons make fun of me, but I manage to stay calm.
This phenomenon happens when a stimulus occurs that doesn't reach the threshold potential. The threshold potential is a particular membrane voltage value that has to be reached in order to fire. In Nellie's case, the teasing did not make her mad enough to reach her anger threshold, and that's why she stays calm.
But sometimes I get really angry when the other neurons leave me out and fire before me.
Also, this is the case when a neuron is stimulated enough to cross the threshold potential. This crossing is what causes Nellie to fire. So what does it mean to fire? Well, zooming into Nellie's axon, you can see that she has many gated ion channels. These are ion channels that open or close in response to a stimulus. The stimulus provides Nellie with two options, to hyperpolarize or to depolarize. The first option occurs when the stimulus makes her less likely to fire. For example, when other neurons are nice to Nellie. Chemically, this makes more K+ channels open, causing potassium to leave the inside of the cell and make it more negative. This causes hyperpolarization, and she is less likely to fire. The second option is when Nellie receives a stimulus, like the neurons firing without her, that makes her want to fire more or depolarize. This is when Na+ channels begin to open, allowing an influx of positive ions, depolarizing the inside and making it positive rather than negative.
Back to Nellie's case, she has reached the threshold and now established depolarization. This initial depolarization of the dendrites where she received the stimulus now will continue to cause other sodium activation gates along the neuron's membrane to begin to open. This causes a wave-like phenomenon to occur where sodium continues to enter the neuron along the axon, making the inside positive as the wave goes through. This is what's called action potential. After this wave goes through a certain point, the sodium gates become inactivated, blocking off the inflow of sodium to the inside. There are now potassium activation gates that open and allow potassium ions to leave the inside, returning the neuron to its original negative state. This process is called repolarization.
Since I've been hurt, I want to act out and hit something. I'm going to send this message to a muscle cell.
The way that neurons communicate with other cells is at the synapse, which is the gap between two cells. Nellie wants to communicate her feelings through neurotransmitters, which are located inside the synaptic terminal. Neurotransmitters are chemicals that travel between two neurons when communicating signals, and to make a muscle contract, the type of neurotransmitter that Nellie wants to send is acetylcholine. This process starts with a specific type of neurotransmitter being encased in a synaptic vesicle. As the vesicle travels towards the end of the presynaptic membrane, the action potential that occurred that wants to transmit into will open the voltage-gated channels in the terminal that allows calcium 2+ to enter the cell. A high concentration of calcium causes the vesicle to bind to the presynaptic membrane of the terminal. Once it bonds, the vesicle opens up and allows the neurotransmitters to be released into the synaptic cell. This type of transport in a cell is called exocytosis. It is when the cell takes substances on its inside and excretes them to the outside.
So, after the neurotransmitter is released, it crosses the cleft and then binds to a receptor portion of a ligand-gated ion channel in the membrane of the postsynaptic cell, the one being communicated with. This opens the channel, allowing both Na and K+ to flow through, and once the neurotransmitter is released, it closes again. This causes the muscle to contract and more.